Okay, so we are recording. Thank you. Okay, thank you everybody for joining us. Sorry for the faux pas there off the bat. I got to make some notes to myself to do that right next time. Let me see here. I'm gonna switch. No, come to think about it, I'm gonna leave it on that camera because that's where my slides are. So anyway, thank you all for joining us this morning, and we will proceed here. We are recording the meetings, and they will be posted to our YouTube channel, and they'll also be linked off of the website. SRS Clips and More is where you can find them if you search YouTube for that. SRS Clips N more, then you should find all the videos that we've recorded so far. Please use the Zoom chat to ask questions, to make comments, contribute links, anything of that sort. And we'll just kind of follow the standard agenda here for those of you that have been here before. Thank you for muting your microphones if you're not actively sharing. And of course, we could all talk at the same time, but it's probably preferable that we take turns. The Zoom chat, you can obviously use that anytime during the presentation. That's a great place to post questions. So Nick should be able to see your questions as you're asking them, and perhaps respond to them as he's going along. And then that I also can capture that, and I'll post that on the weblog of the meeting, so you can go back there and find information if people included that. It's something that's very interesting for you. Nothing new on a new physical location. First Washington. Last time I emailed Kevin Ross fairly recently, and he says that he hasn't heard anything yet about a specific location. So, but we are hoping to get something kind of in the vicinity of where our previous venue was, which was down in Kent. So, but could be anywhere between Kent and Tacoma. So we'll see what happens. All the gear and everything else is still in storage in the meantime. So, but we will continue to do Zoom meetings when we do resume in person. So those of you who are not locals can join us. So that'll be kind of fun. We've not done that before. And so that will probably require a little bit more effort on my part. And so I'm hopeful that I will be able to volunteer one or two of you to help me out with some of that stuff at the actual venue. So I will be looking for people to just kind of help keep all the equipment running and the background of the administrative stuff and the behind the scenes stuff, so that we can bring in as many people as want to join us. I'm continuing to do weekly robotics classes with some junior high kids at a church in Burien, and we may use these robots, or we may move on to some other ones. I'm looking at MBOT, which is one that Dave Anderson from the Dallas Personal Robotics Group recommended is a good one for getting kids started with robotics. So. But I'm always open to suggestions if anybody else is aware of any good kit candidates out there. I'm actually, sometime in the next couple of weeks, I'm hoping to purchase some kits to use. So I'm always interested in ideas for how to teach the kids, and particularly I want to get into the programming elements of these things. So kids are good at playing with these robots, but it's like, I think, taking them to the next level of learning how the programming works and how to program them. And there's so many cool graphical methods available now for a lot of these robot kits. So, drag and drop programming pieces into a kind of a stack and then run that. And so I'm kind of looking at that kind of an approach. Let's see, Drive Electric Week just concluded here. Let's see, what are we? That was about almost 2 weeks ago now, and I attended a live event up in Mill Creek on the 25th of September, which was great fun. And I would let's see here. see if I get the, I will, all right, get updates. And so you seeing some pictures of cool electric cars there, I hope? No? Okay. I gotta share a little differently here. Then I probably need to share desktop. Okay. That should be better. Okay, now? Good. Okay. So there was about 25 cars, drivers and cars showed up at the event. We had, of course, you know, a number of Teslas. We had a couple of my Leaf, another, I believe it was a 2018 Leaf that I'll show you a picture of. This little Leaf here is kind of cool. The guy that owns this one, he put different kinds of wheels on his. These are steel wheels that he put on this thing, and it looks pretty sharp. I mean, that's a great color that he's got there, and he wanted to sort of make it look a little, you know, stand out a little bit from the crowd, and I think he did a pretty good job of that. Let's see, this is the Hyundai Kona, is that right? And this is my car, and I was using a power inverter, which you can kind of see right there, that's sticking up at an angle. It was just kind of sitting over next to the 12-volt battery there. So it's a 120-volt power inverter that I was running these lights with, and I was actually running my computer with it as well, and just kind of demonstrating using your electric car as a backup power source in the event of an emergency power outage in your home. So, and let's see, this Chevy Volt here, and this thing. So this is a Jeep let's see, what they call that. It's a 4xe, and so it's a hybrid. And this guy, you can tell he just got back from having some fun running around in the mud. And he when he pulled in with this thing, the folks were kind of like, at first were kind of questioning, well, what are you doing here with one of those? This is an electric car event. But then he was on total electric mode, so it was completely silent as he was driving in, and they realized that it was a hybrid. And I'm gonna show you, this is the battery in the thing. So underneath the back seats there, that's basically pretty much it. It just kind of runs all the way across the car. Not a very big battery, so it's got like 20, I think he said around 25-mile range, something like that on pure electric. So so we welcomed him. You know, that's a no less of a electric car than a Chevy Volt as far as being a hybrid. So that was kind of cool. Nice, pretty blue Tesla here. And then this was, let's see, Kia electric car over here. Yeah, there's another little kind of a view of the side of that thing. It was kind of a mess, but he decided to just leave it. Mustang Mach-E. And then this guy over here, he had a Chevy Bolt, and then he brought an electric bicycle on the back of the thing to kind of show that. I thought about bringing mine, but unfortunately the weather was kind of iffy, and I didn't want my bike to get drenched in the rain. It always it's a big mess to clean up after everything's gotten wet. So I decided not to do that. There's a better look at the Bolt and another Tesla, and I'm going to show you something kind of fun with the gal that owns that. This is let's see, this was a Harley Davidson electric motorcycle. And this gal you made her bought these things. They're a couple of they're cardboard, but obviously they made to look like big AA batteries. And so she had these in the front of her Tesla. And she actually had somebody come up to them and look at those and go, "Are those the batteries that make your car go?" And I told her she should have really played that, you know, and said, "Well, yeah, of course." And anyway, so that was kind of fun. It was like, oh, where could I get some of those? That's just too much fun.
No, that's Steve.
And then this is the other Tesla, or the other Leaf that was there, one that's the Gen 2. And so there's another view of the Bolt. It did not spontaneously combust, fortunately. And then there's an electric bicycle. A little closer look at that. And then this was, let's see. I think this was, trying to remember if this, which car this was now, but let's say on the front there, yeah, it just says Eco Technology. So, and a food truck.
With the buttons.
Oh no!
Yeah.
I tried
It's half an hour.
it.
Very pretty Teslas.
Again, I fixed my login, so I'm still logged in. So I'm sitting down.
Hey, Richard, I think that's you.
Oh, I'm sorry.
There we go. Thank you. So, and this fella does a lot of traveling with his car, so he has an adapter that allows him to use Tesla destination chargers to charge his car. And there was a pretty red Mach-E too. Then we had a couple of those there. And then another view of that guy. So anyway, those were the that were those guys. So this was this particular event was the only live event in the area during this week. At the 2 weeks prior, 2 weeks, yeah, 2 weeks prior, there was one at Silicon, and they said that was actually pretty well attended too. But there were the only two live events in the whole area. The one out at the Issaquah XXX Drive-In did not happen, unfortunately. And so I really wanted to go to a live event because it's just way more fun than trying to do something on the computer. You know, it's just so. Anyway, strongly encourage anybody that's got even a little bit of an interest in this stuff to if you have opportunity, they'll do these things, maybe do these things a couple times a year. So. And let's see. So a little bit later on, we will have Nicholas on. I should have asked you how you pronounce the correct way to pronounce your name, Nicholas. Could you jump in there and how do you say your
Fragale?
Fragale.
Yeah, Nick Fragale.
Nick Fragale. Ah, I like that. As a kind of a is that Italian?
Yep.
Okay, I was thinking it's just that it has that wonderful Italian feel to it. So cool. So Nick is going to be sharing with us about a company that he co-founded, and he's coming to us from live from Minnesota. So he will be up a little bit later, and I think this will be great fun. So looking forward to that, and always appreciate assistance in finding presenters. And Robert Kellogg continues to feed me usually at least a couple, 2 or 3 a week. And it's like it keeps me busy just getting out, reaching out to all these folks. So, and he was one of the ones that suggested Nick and some of the other presenters that we've had the last few months. So anyway, that's been great. So send me emails of if you find something interesting that you want us to, so we can try to see if we can get them to come and talk to us, because always looking for that. And that's one of the reasons you guys like to come on these meetings, is just to hear about what's going on out there and what people are doing. Let's see. I'm gonna keep reminding you guys about this. So at our February meeting, it will be a special one-time afternoon time frame for us here. From 3 to 5 p.m. to accommodate a presenter that will be coming from Japan. So it's going to be in the morning for him. I believe he'll technically be Sunday morning for him. So he'll be presenting to us live from Japan, and so that will be. It's on the website, and there will be no 10 a.m. meeting, Pacific time meeting as normal on this one particular month. And this I will only do this when it's absolutely necessary to do it. I know, shifting things around can definitely confuse people. So I will continue to remind you right up to this. So, and I guess I should send out something to the group's IO list too, and make sure I do that for sure for this meeting. So anyway, and here's here's the lineup that I currently have out there. So we have a bunch more cool presentations coming, and so anybody out there who would like to jump in, April is potentially movable. That's a facilitated discussion. I usually lead those. We can that can easily be moved out of there because those are just kind of presentations that I have in my hip pocket. I'll pull those out and use them as filler wherever necessary. But I prefer to get live presenters if possible. But the discussions are always fun too. I know we have a good time talking about whatever topics. And speaking of that, here's some ideas. You guys have seen these before. If you have any others that you think might be a good possibility, let me know. I'm also more than happy to let anybody lead the facilitation. I don't mind doing it, but it's not particularly difficult. I usually just go out, do a little bit of research, kind of get some ideas for stimulating questions, and then just kind of throw it out there. And you guys do all the work during the meeting. So it's pretty easy. And, nobody needs to be an expert on any one of these topics to be able to do one of these. So keep that in mind. And I don't know, let's see, I guess I should look at the participant list here to see if we have, I didn't see Lloyd jump on today, so I don't think, no, I don't think there's anybody else here that specifically knows anything about, I can talk about it. I attend the Robothon planning meeting, so I can talk about the upcoming virtual event. Hopefully you've had a chance to watch the video that we did for the July 10th event, so you have a kind of a flavor for what that's about. So presenters, there's usually a 2 or 3 presenters prior to a break, and then 2 or 3 more presenters after the break. The goal, each presenter's talks approximately 20, maybe 25 minutes max, and shares a project, videos, just kind of talk about whatever's interesting to them. And it's just a short, condensed, kind of compressed presentation. It's sort of an alternative to our Robothon event. We obviously would like to be able to do live contests and all of that, but until we can actually get back out there and do that, we're going to probably do these things. So I'm not certain how many people are lined up for November 13th, but that is, I believe that's the second Saturday in November. So it should be a week prior to our November meeting. And let's see here. I'm going to take a look on my phone here and see oops, that page not found. Oh, okay. Looks like she's updated some links here. Okay. Oh, that's interesting. Huh. I get all I get is, unfortunately, due to public health situation, King County COVID-19 Robothon event has been canceled, and I don't see a mention about the virtual event. So do not know what that's about. Okay, well, anyway, the virtual event will be happening. So you can go to the robothon.org website, and there's a place to sign up, and there's a short form there you can fill out with your information, and then Donna is kind of coordinating that, and I believe that Lloyd will be hosting it. So it will go from noon to roughly 3 in the afternoon on November 13th, and that's a great opportunity to kind of practice your public speaking skills and just kind of get share whatever it is you've got, and doesn't, and like I say, it's got, fairly short presentation, so it should be should not require a ton of preparation if you've got something. And if you've got, ability to show any kind of live demonstrations, that sort of thing, there's opportunity for that. So let's see, I think this is almost done with my rambling here. Last thing is we've got a couple of, we have a couple of kits that the club essentially is sponsors for people that want to give robotics a shot, not too expensive. This is an Arduino Uno based kit, $125. If you're not local, it might be a little bit of a challenge to acquire these, because we don't sell these online or anything like that. They typically are purchased in person. So if this is something that you are really interested in, you can reach out to me at the email there, and we can work out an arrangement to meet up with one of these. And there's two different kits here. This is a propeller based. I kind of cheated there. I realized that I just realized that the images are identical between these two slides. I probably ought to really find the picture of the other one, but I don't think I found quite as nice of a picture of the kit. So the kits look roughly the same, other than the board on the robot is a little bit different because it's got a propeller processor rather than the Arduino Uno. So the robot kits are the same overall structure and form though, and the sensors and everything else. The main difference is that with the propeller chip, you get an 8-core processor, so you can do actual true multitasking. And so that's the primary difference between these two kits. The Uno, it's a pretty simple processor, runs one program at a time. The propeller can run essentially up to 8 simultaneous programs. So a little different kind of an environment for programming. So anyway, keep that in mind. Virtual workshops, we will continue. I may have to kind of bail out on this. We're going to have some guests coming for brunch here in a little not too distant time. So I may have to bail on a post-meeting workshop, which normally just ends up being a kind of a discussion where we just chat about robots and whatever topics are interesting. We don't normally record those, so anyway, keep that in mind. And let's see, around the room. So opportunity, somebody out there got something to share, an update for something that they've been working on. This is an opportunity, and I'm going to stop sharing here so somebody else can jump in. So anybody out there got something that they're just dying to share with the rest of us?
I made a dumb
volunteer one. Go ahead, James.
I made a dumb little thing that I'm kind of proud of.
Awesome.
I got to use this for a class that I gave yesterday. And basically all it is a really stupid, simple little printed circuit board that allows you to plug in some servos, and then has pins up here at the top to connect to a microcontroller. So, for example, the ESP8266 or ESP32. And it just provides an easy place to connect like a battery power pack to the power source. Yeah. A little header here, and you hook up your servos to it, and use one of the data pins for producing the PWM signal, and it runs out into this little so you go. It's mostly for mechanical stability, and then making it easy to hook up the power. And it has pins that can accommodate different layouts of the power rail on the whiteboards, on the little breadboards. So you can do it a couple of different ways. Anyway, I used that to do a fun little class with the robot that we made down here at the Makers Guild, which uses the cell phones. I've talked about this before, to do recording, and then save it and play it back. And it also has an online web editor that allows you to edit the files on board. So that was my fun little thing.
Wow, that's like really cool.
Thanks. You know, the funny thing was, I figured that would have already been done, and I looked everywhere for it, and nobody has done one of those. So I went ahead and did it. What the heck?
Wow.
Yeah.
You know, that would be a great virtual Robothon exhibition talk. Think about it.
Well, I'm already doing the one for Dexter in May, so. But actually, that combined with the SDMG bot and the way that it allows you to do, it becomes a little mobile web dev platform for like literally $20 that you can edit files on it, and then you can control it, and then you can animate with it, and then you can do autonomous mode with it. There's so much that thing can do, and I'm just kind of amazed that more people aren't playing with it. So yeah, put me down. I'll do one of those when you have your next open slot.
Okay. Of course, that would be, yeah. I would like to. I'd like you to do that for one of our meetings too. Although I've got I think I've already got you for March next year, and April is like an open slot. It's like, how about I could do you both March and April if you want.
No, it's best to give somebody else a chance to get in there in between. Also, we're working on adding Scratch to that, so maybe we'll have that done by then.
Yeah, that sounds like that's pretty cool.
So you were talking about doing that as something else, or
so on November 13th for our virtual Robothon exhibition. So that's that's a short, 20 minute type of talk, so it would be very brief. You wouldn't be able to go into the much technical detail in that amount of time, but it would be an opportunity to sort of just put this thing out there and talk in general about what it does and how it works and how you did it and things like that. And then
count me in. I'm happy to do that.
So just go to the robothon.org website and sign up for that. Donna would be very pleased.
Can do.
Okay. Well, thank you so much. That's really cool. I'm be interested to hear more about that. So, okay. Anybody else got something that's just burning a hole in their belly? Gotta share, right? Come on, guys. Shirley. Is Shirley out there somewhere?
I can give an update.
Okay. Thanks, Greg.
Okay, so I don't know if I shared this last time. These are the circuit boards. Just a second, let me turn off my background so we don't have things disappearing.
Yeah.
Hello.
Let's see.
Choose virtual background. Oh, there we go. None. Okay. So this is 2 circuit boards. You can see there, one on top of the other. The intent of this, if it works, is to drive up to 6 stepper motors. The driver board being the large one on the bottom, the kind of the interface and brains of the board is the smaller one on the top. This is the most complicated set of boards that I've done. So my plan was not to try to do all those surface mounted parts using the hot air gun like I normally would, but to do them on some sort of a reflow device. I'm opting for a reflow hot plate, and to control that reflow hot plate, I've designed this circuit board. Just came on Thursday. This is the controller board. This is the interface board. This is the AC side of the board. It'll have an ESP8266 here, a couple MOSFETs over here for turning it on and off. So that is my kind of distraction project, or my tool project, to create something that will allow me to more easily fabricate the other board. But then my distraction project from this, I thought, I have a tool for cutting the boards. I hope to now have a tool for doing the reflow on the boards. Obviously, the boards get fabricated professionally. Putting the parts on the board was kind of the missing piece. So my current distraction project is a pick and place machine. I'm going to try to keep it simple and use a SCARA arm for that. For those that may not be familiar, a SCARA arm is one that moves just on a single plane. So imagine that you've got two pivot points here. You've got a shoulder and an elbow, and they both swing horizontally. One of the goals, or one of the design constraints that I'm placing on myself for this project, only to make it more challenging, is I want to try to build it with only parts I already have. So I have some surplus belts. The size is based on the belts that I have. I've got the extrusion, I've got the acrylic, I think I've got the stepper motors. So that's part of my challenge, is seeing if I can put this thing together with just things I have. The last part that's kind of still in design mode is the tool on the end. It needs to have a vacuum for picking up the parts. It needs to slide up and down. I'll use a servo for that. Some leftover linear bearings that I have, and perhaps I can get a machine that has just enough resolution to be able to place the parts on these small boards. So the other actually distraction project, I'm a member of SNOCO, and I thought, wouldn't it be fun if we had some name badges? So I've made this cute little name badge. It's got a hole in the middle here. There will be a 0.91 OLED display mounted in the back. So you'll be able to see that through there. So you can put your name or whatever other message you want on it. And there's a commercial product. I'm not sure you'll be able to see it. There's a commercial product called a TAG, T-A-G connector. And right up here in the corner, there are 6 little pads with 3 little holes, 2 on the bottom, 1 on the top. The TAG connector is for, it's for your in-circuit programming. You don't want to take up the space for a full-size connector. Maybe you don't even want to solder a connector on. So you've got 6 bare pads, these alignment holes next to them, and then the TAG connector has little pins and pogo pins, and you can press it up against there and do your in-circuit programming. The TAG connector is about $35, and I'm too cheap to buy one. So the last couple of days I've spent trying to make a set of pogo pins. You can get these from Adafruit, tiny little 1 millimeter diameter spear point pogo pins, and using my resin printer, trying to fabricate. Now this is the the tip of it. The spacing on those pins is 0.05 inch. Okay, so you've got a 2x3 grid, 0.05 inch spacing. And so I'm trying to use my resin printer to make a little holder for those. I've managed, much to my surprise, to solder 6 of those pins onto the end of a ribbon cable. And of course, the other end of the ribbon cable has your standard socket for in-circuit programming. And so the plan is to poke those little pins and the guide pins into that 3D printed part after passing the ribbon cable through this, which has some rectangular holes through it, and then put some shrink wrap around it, or heat shrink tubing to kind of hold it all together, and hopefully I'll have a nice little pin shaped connector that I can use to do the in-circuit programming on boards that you don't want to give up more real estate for that. So those are my robot and non-robot distraction projects.
So to do that programming, are you going to hold that in place by hand? Is that the idea, or is there going to be a?
The people that make the Tag Connect, they make 2 versions. One that you hold, and then one that's got little fingers, and then you put additional holes on the side that they hook into. I didn't want to give up that additional real estate for those holes. So I'm building mine without the little fingers, though I did revisit their website, and I saw that they sell a little clip that goes on the other side that grabs onto the guide pins to hold it in place. So I'll try fabricating that. If that doesn't work, then I figure I'll just 3D print something kind of shaped like this that goes under the board and then grabs onto the little handle I'm making, so that that'll hold it in place.
Yeah.
Hey, Greg, if you're making this as a name badge, you probably are already planning on holding that onto your shirt with little magnetic clips. And magnets are great for holding pogo pin things down.
Oh, okay.
Yeah. Yeah, the rare earth magnets out there, man, those things are so ridiculously strong. Yeah, might be able to.
And if you ever need any more pogo pins, just reach out to me, because I have full kits up to like 4 millimeters in diameter.
Oh, is that right? These are 1 millimeter diameter. I went to lay out a board to solder them into to hold them, but then realized with that 0.05 spacing, there's not enough room between the pins for a ring. So I had to hand solder them onto the wires.
My last China trip, I went to one of the electronics malls in Shenzhen and just bought, 100 pack of every size and every size of guide pin they had, because they're just handy to have, and it's just easier to just buy one of everything.
Sure.
Yeah, I now that I've started using them, I can see myself using them more in the future.
And if you get really fancy, Pomona sells a set of voltmeter probes with pogo pin guides. So then you can just slide in whatever type of pogo pin you want into your voltmeter probes.
Oh, nice.
Yeah.
Nice. This is another one of the examples of, I order from JLC PCB in China. You get your almost 4-inch by 4-inch. I laid out this part based on what I needed. And then I had this square up in the corner going to waste. And this reflow controller uses a particular thermocouple amplifier. And I have a few of those chips, and I wanted to do some testing of the heat distribution on my hot plate before I actually commit to where I'm going to put the thermocouple. So these are a couple breakout boards so that I can wire up some more of those thermocouples for kind of a testing, which left me with this blank in the corner. I said, what can I use that for? Oh, I can make a little name badge. And one of the colors, one of the kind of the brand colors for Sunoco is purple. And JLC just started selling purple boards.
Oh, nice.
So I thought, I'll order it in purple. We'll get to see what the purple looks like. And I got the little purple name badge.
Cool. Wow. All right. Thank you, Greg.
Yep.
I'm going to, let's see. Okay. Anybody else? Because if not, I'm going to go back to just put this up here for a sec. Okay, so before we break here for a short bit, just a reminder that the Zoom links are the same each month, so keep that in mind. The meeting recordings will hopefully be posted not too distant future. And then, of course, check the website for meeting detail updates, and feel free to send me presenters and feedback at the Seattle Robotics Society Gmail, and put information into the chat there if you've got anything. And so with that, we will take a break. I think we're going to probably do it a little bit less than 10 here. This is just a little YouTube video that does a 10-minute countdown. So I'm going to go ahead and start that and kind of run downstairs and greet our guests that have started to arrive. And then I will be back up here to get things rolling in probably about 6 to 7 minutes or so. So. Come on, there we go. Oh, that's interesting. Okay. Well, maybe guys, yes, I'll go ahead. Let's see, Nick, why don't you, there you are. You're all ready to go, right? I'm gonna just take a little bit more time off of this. Give it another couple of minutes here, and then just kind of looking through the cameras. There's like a lot of people have just stepped away from their computers for the moment, so I think I'll just give people a couple of minutes here to. Oops, yeah, it looks like every time I touch something, it stops the countdown timer. So I guess I got to stop doing that.
They stepped away to get away from that music.
Yeah. Sorry about that. I wonder if there's a. Yeah, I don't see an option to mute it, unfortunately. So I guess you just got to turn your volume down a bit. Okay, enough of that. Let's see here. All right, let me see. Come on. Oh, there we go. Okay, so let me see here. I'm guessing. Let's see, you guys can probably seeing my desktop there with a little bit of stuff about Nick. Okay. So I'm going to go and shift this over so I can see him. There we go. Okay, Nick, I'm just a brief introduction here. So Nick is a co-founder and CEO of Rover Robotics, located in, is that Wayzata? Is that how you say that?
Wayzata.
Wayzata.
Yep.
Minnesota, and he's on the previous slide there. That was a picture I grabbed off your website of your warehouse. Then you have that entire facility.
Yeah, and that's actually our manufacturing facility.
Cool.
Yeah.
Okay. Well, love to. Yeah. So you're your lead robotics engineer there, and you've been doing that for looks like a little over 5 years now. That's pretty cool. So we do greatly appreciate you joining us this morning. I'm going to go ahead and stop sharing here, and you can go ahead and start. And thank you for joining us, and we look forward to your presentation. So take it away.
Awesome. Thanks, Steve.
You're welcome.
Yeah, I really enjoyed the round table, getting to see what everyone's building. we're doing quite a bunch of kind of similar projects at Rover Robotics. So it's always fun to see what other people are working on. Steve did a pretty good job of introducing me. I'm Nick Fragale. I'm the CEO of Rover Robotics. We're a pretty small company based out of Minnesota, and our main goal as a company is to democratize the use of ground robots. And I know that phrase gets overused a lot, but I think that ground robots really can use it. There's a lot of expensive robots on the market that are really only accessible to large companies with big budgets and not really accessible to the hobbyist community. And then there's kind of a separate hobbyist community set of hardware or educational robots that are sort of $1,000. So we live between those two. And if you visit our website, we have 3 main product lines. So this is just roverrobotics.com. This is our shop page. We list all of our prices online because we're very much for openness and sharing our price points, which a lot of other robot companies don't do if they're very expensive and they want to sell mainly to businesses. So these are the 3, and depending on your screen size, it might be a little bit hard to see the prices. It might be getting a little bit small, but the Rover Pro, which is all the way on the right, it starts at $8,000. The middle one, the Rover 02, that one starts at $3,000, and then the Rover Mini. We were planning on doing a Kickstarter, but that got delayed because of the chip shortage. But we were planning on doing a launch price of $450 and then launching it at around $1,000. So this is kind of the motivation for our company is when I graduated from a robotics degree, it was hard to access kind of the expensive, nice robots. It's not something that you can purchase as an individual. If you want to start a company doing some application, they're quite expensive. So you kind of have to take out a large loan, or you'd have to have previously exited another company or something in order to afford them as an individual. So most of these are bought by large organizations, big companies or universities. And so you have the Boston Dynamics Spot on the upper right that starts at $75,000, which is an awesome piece of hardware. Just wish it cost less. And then the ClearPath Husky on the bottom right, and that starts at around $30,000. And I got to use the ClearPath in my university work. And it was pretty good. I'd say it's not something I would want to base a company on. It's not quite well thought enough or rugged enough, but it still costs $30,000. And then on the other end of the spectrum, you have on the left side, you have the TurtleBot, which is one of the most popular robots for teaching ROS or getting into robotics at $600. And there's a whole slew of other educational robots that look very similar that are usually sub $1,000 and can get down to $100 or $200. But all of them are very much geared towards education. No one would go out and do a business use case with them. They kind of are just for teaching purposes. And we were very inspired by the company DJI and their success in the drone business. They came out with the DJI Phantom series back in 2012. Around that time, the same thing that exists right now in ground robotics was the state of things in the drone market. There's people who built their own drones, and you could usually do that for under $1,000 if you wanted to, but certainly under $2,000. And if you didn't build your own drone, you're buying a very expensive drone. Maybe you're shooting movies and you're buying $100,000 octocopters or things like that. And there really was no in between. And when they launched the DJI Phantom series, it really brought the two worlds together. And all of a sudden, you saw both movie producers start buying these, and the same people who are building drones started buying these, because the tech just got so good that you couldn't build a drone for cheaper than just buying one off the shelf from DJI. That's how good their technology and their cameras got. And so it's really a powerful thing when you bring these two worlds together, and you get really good tech at a low price point. And so that's what we're hoping to do in the ground robotics space.
So Nick, you have your chat window open, I assume, so you can see questions that pop in?
No, I have my slides full screen. So if there's any questions.
How about if anybody has any, well, it's helpful to just for archival purposes, if you can put questions into there, but you know, anybody feel free to, I assume, feel free to jump in with questions as you're going. Okay.
Definitely. Yep. Just feel free to interrupt.
Okay.
Presentations are better as a conversation.
I agree.
Any questions right now? Okay. So a little bit about our Rover Pro Series. This is the first one that we released back in 2018, and here I have a comparison to the Spot Mini. So you can see a lot of the hardware aspects we actually can do better than the Spot Mini, but a lot of the software aspects, that's where the Spot Mini really shines. So we focus 100% on the hardware so that our customers can focus on the software side of things. So it starts at $8,000 roughly, has a runtime of 5 hours, payload capacity of 100 kilograms, IP67 rated, so you can actually drive these through puddles, through underwater, and they'll survive. They're completely environmentally sealed. And we can offer that all at a much lower price point than the Spot Mini. Obviously, we don't have the same level of autonomy software included, and so we leave that up to the user. But we allow them to customize. You know, we allow them to just purchase the hardware, because we think there's a lot of people out there with ideas of what to do with robots, and if it's just Boston Dynamics thinking of, okay, here's what we think robots should be used for, then we'll miss out on all those ideas. So we don't.
A question.
Yeah, go ahead.
What's the physical size of your Rover Pro?
Yeah, it's so it actually fits like perfectly inside of one of the large 50-pound suitcases that you'd bring on a plane. That's about the same size. Another way of saying the size is like a desktop computer with wheels on it.
Okay.
Yep.
So is that roughly 16 inches square, something like that? 20 inches?
Around 20 inches, I'd say, squared. I'm forgetting the exact dimensions, but it's around 20 by 20 by 10. These are 10-inch wheelbarrow tires, also, to give you some reference. So they're exactly 10 inches on diameter, and the wheels are pretty close to each other. So yeah, a little over 20 inches long, 10 inches tall, and then it's about square. So it's about 22 inches wide. So one of the main differences between us and like a Boston Dynamics is that we don't include like the sensors or a computer inside. You put that all in the payload, and then this base is just for mobility. But it gives you nice to have things for robotics. So things like the battery state of charge, the battery temperature. It gives you motor temperature and wheel odometry. Things like that that are needed for autonomous operation. So that was in 2018 that we launched that product, and we started becoming popular for like universities to buy, and for industrial inspection applications, but still we found our price point wasn't low enough really for what we wanted. We thought the difference was that you couldn't really buy it on a credit card. And I think that's the big difference for a lot of organizations or individuals, is if you can put it on a credit card, then it becomes a lot easier to purchase. So we went back to the drawing board and we looked at the max temperature, and the Rover Pro has these heat pipes inside and a active fan, so that if you're operating on a really hot day, like 120 degrees out, and maybe the asphalt is 140 degrees, it still remains cool and continues to operate. But we found a lot of people didn't need that, so we got rid of all that active cooling. That bumps the max temp down to about 100 Fahrenheit. Then we went with a cheaper off-the-shelf battery that isn't quite as large. And then we removed the ability to use a charging dock and got rid of that circuitry. And we switched from our vibration resistant high current motor controllers to an off-the-shelf open source design. And that all those changes allowed us to get the price point down from 8,000 down to 3,000. And that really got us to where we wanted to be, where we saw people actually just purchasing these with credit cards off of our website, and without having to talk with our team a whole bunch to figure out if it's the perfect robot. We kind of reached that threshold where people maybe feel comfortable just reading the specs online, and it's a low enough price point just to buy one and try it out. And that's what we were really going for. So here's one of our customer case studies. This is Zach. He's a CEO of a company called Coco Robotics. He was a college student, graduated a little over a year ago, right at the height of the pandemic. And he had the idea that he thought that the current autonomous or the current sidewalk delivery robot companies were kind of doing it wrong, and they were focusing too much on autonomy, and there was this big need for robots to do delivery, but they were waiting on the engineers to finish the autonomy software before really rolling it out. So he had the idea, why don't we just stick cell modems on these and have people drive them around, and then we'll get a bunch of these out on the street, and then we'll figure out the autonomy software later, kind of like the Tesla approach. So that was a year ago, and since he's bought 150 of these, and they're delivering food out in California, and he's raised $43 million, and they're building these on top of our Rover Zeros, which are cheap enough where for the first one, he just bought it on a credit card after graduating. It was cheap enough for him and one of his buddies to split the cost, and he was able to come up with a demo and go pitch investors and raise a bunch of money, which is really cool and exciting for us. This is exactly what we were hoping would happen. So I wanted to explain a little bit about what it's like to develop on our robots. So it's our Rover Pro is on the right here. That's the top of it, and the Rover Zero is on the left. So the Rover Pro has a DB25 port on top. Inside is nothing but motor controllers and batteries, and so it needs something to command it. So you mount a computer on top of it, and you use what we call our interface board, which has a DB25 port that breaks out to USB, and then you can send commands over USB. And then on the left we have the Rover Zero, which we just replaced that DB25 port with a bunch of cables. One's USB, one's a power cable, so you can power your computer, and then you command the robot via USB. And then we have these 8 M5 mounting points on the top, and we have 4 more on the back. And so you design your payload to attach like that. And then in the upper left-hand corner, we have what we call our R&D payload. So if people want to have an idea for a payload, but they want to have something to work with initially to get a demo up and running quickly or something like that, we offer this R&D payload, which is just a sheet metal enclosure that you can mount sensors to, and it's big enough where you can mount your computer inside. And then the idea is you load ROS or ROS2 on the computer, and then we have a open source driver that you can easily command the robot with. And one of our big kind of design philosophies is that sensors and computers should go into the payload and not into the robot, and that's because sensors and computers, most sensors and computers, I should say, are changing very fastly. NVIDIA is releasing a new computer every year. Intel RealSense was releasing a new stereo camera roughly every year. Until recently, they announced that they're going to shut down production of those. So when we saw that announcement, that kind of was kind of like a yeah we chose the right path, because like a Boston Dynamics, who's built the Intel RealSense cameras into their robot, they now have to figure out a replacement for those, or risk stop production of their robots until they can find a replacement. So since these things are changing so frequently right now, we just recommend to stick it in the payload, and then it's easier. You don't have to redesign the whole robot if one of these comes out with a newer one or goes end of life or something like that. So then our newest product is the Rover Mini. This is the one that we're planning on launching earlier this month on Kickstarter, but we had to delay that due to the chip shortage. We had to start designing, and now we're reconsidering just posting it as an open source project. We had designed custom motor controllers that are very cheap, based off a Infineon ASIC that does BLDC control, and we're using 4 hoverboard motors, because the hoverboard motors are really powerful for the price point. You can get them for really cheap, and the torque is just insane for the price point. So just to give you an idea, we were able to pull a car in neutral with one of the Rover Minis using just 4 hoverboard motors, and we could actually pull something a lot larger, but it's mainly limited because of the battery and not wanting to light the battery on fire. So yeah, so here's our inside of our Rover Mini. On the right is kind of the custom boards that we had prototyped. These are just ones that we bought off of OSH Park, just to get an idea of how they fit into the chassis and stuff. They're not populated with chips or anything. That's partly just because they were just for fit and function, and partly just because we couldn't actually get the chips for these in a reasonable lead time. So for our prototypes, we used these open source motor controllers, the same ones we use in the Rover Zero. They're from a company called FlipSky, and so that's called the FSESC for FlipSky Electronic Speed Controller. And so now we're thinking we'll probably release the Rover Mini as an open source project, and just use the same motor controllers that we did for the prototypes. So you can see here's kind of the guts of the robot, and the chassis. It's kind of hard to tell from this picture, but it's actually 3D printable on a Prusa, and that's how we created the prototype. So you can 3D print your chassis. You can use these open source motor controllers. You can use hoverboard wheels and a hoverboard battery. Each of these motor controllers can control 2 motors. So you need 2 of them to do the 4. And then you can communicate between the 2 with CAN, and then you communicate to a computer with a USB cable. And since the 2 are tied together via CAN, you can see all 4 of them and just write to the specific CAN address to control each motor. So yeah, that's it. I guess there's a few other things I wanted to show. Just here's the motor controller that we use that I'd highly recommend. It's gone up a bunch in price because of the chip shortage, but we're hoping that it falls. It was more like $160, so it was a pretty cheap option for doing two brushless motors, and it can do quite a lot of current. And this is based on the VESC project, which is a open source project that releases all of its electronic files and firmware and stuff. And then, let's see, I was going to show on our Rover Mini page, we still have, here's a GIF of someone riding it around. So it has a huge payload capacity because of those hoverboard motors. And since they're designed for kids to ride around on, if you put 4 of them on there, this is Davis, our mechanical engineer. He's 300 pounds, so you can carry a lot of weight, which is pretty cool. And then they're meant to be pretty fast for zipping along sidewalks. This is no longer relevant because we'll probably not have this custom PCB inside of the robot, and we'll probably get rid of this and just have the back be covered. But you can also, we posted our CAD so far, and we'll probably be posting all the electronics and schematics and stuff so that people can build these themselves. So here's the CAD. Each of these chassis components is a mirror image of each other. So you just need to print this twice. And then inside, let's see, inside you can see here's where the battery sits, and here's where there'd be in this design there is a motor controller in each corner because we had the custom motor controllers, but we have some redesign of this to do before we release it, so that people can use the off-the-shelf motor controller. But that's what we're working on currently, and we're looking kind of for feedback from the community on how exactly they'd want this, whether people would want to print it themselves and just purchase the wheels, or if people would want to purchase it as a full kit. We're debating doing both, but yeah, so that's something that we're looking for feedback on. But yeah,
hey,
so that's
I found a link to the VESC project, but I can't find the link that you shared for purchasing it for just the PCB. All the ones that I can find are in a metal case. Can you share that link into the chat, maybe?
yeah. This company FlipSky is actually I think they're Shenzhen based, and they're one of the kind of like unofficial creators of this. So the VESC project was created by an engineer called Benjamin Vetter, and he kind of got angry at the community for companies like FlipSky that sell these and then don't contribute back to the main project. But they do sell them for significantly less, so we still purchase them from FlipSky. But that's one consideration, buying them from FlipSky or another company.
Like Arduino clones.
Yeah, exactly. Yep. Yeah, so that was it for my presentation. Happy to take any questions. I wrapped up good and early so that we could have some conversation.
I was sort of curious about the structural like integrity of the body. So you were talking about part of it being like 3D printed, but
yeah, the entire
is it really the 3D printed structure of it that holds the wheels together? And don't you find problems with that torquing or bending or like falling apart over time?
Yeah, so the entire structural part is the 3D printed part, and I'd say it holds up very surprisingly well. Like it bends a little bit when you have a very heavy person, like over 250 pounds on it, and it does degrade over time. It'll loosen up, But you can just 3D print a new one, which is the cool thing. And it'll last you, like if you're not putting a whole lot of weight on it, I'd say it'd probably last a couple of years before you have to reprint a new one.
What kind of material are you using for the 3D print?
We're using PETG so that
Okay.
if you leave it in your car, that it doesn't melt and warp.
Just out of curiosity, has anybody tried printing it out of carbon fiber, like on a Mark Forge or one of the Prusas with the carbon fiber?
No, I didn't know that the Prusas could do carbon fiber.
Yeah,
That'd be very cool.
They have a kit. Last time I checked, and this was a while back, but it was like $1,400 to get up and running on carbon fiber. The trick is that the nozzles wear out, I guess, fairly quick, but still, that's not too bad.
Yeah, that'd be interesting to do. So it takes pretty much the entire Prusa bed to print. So anything that's smaller, any printer that's smaller than a Prusa is either not going to be large enough, or you'd have to stitch multiple prints together.
I was wondering, what is it like to mount one of those wheels, since the bearings are all in the wheel, right? So you have a fixed something sticking out of the back of the wheel there that you're mounting. So is it just like 4 screws, or what's that look like?
Yeah, let me see if I can find an image online. It's usually 4 bolts that hoverboards use. And so there's a stem sticking off of the motor, and then you have a metal piece that you clamp on with the 4 bolts. Here, I'll share my screen again. Here's the typical hardware that you use to mount these. So you can see it has 4 bolts and then 4 holes in the corners, and then this is a flat side, so that's the keying feature to keep the stem from rotating when the actual wheel rotates. And I'm trying to find an actual taken apart hoverboard. To make the prototypes, we actually went to Target. They have these $130 hoverboards from a company called Ride On that we just took apart. And here's kind of like,
there you go.
Here you can see one mounted. Yep. So it's super easy to mount them, which is one of the nicest parts.
In that picture, that lower piece of aluminum, of flat aluminum, that would be instead the 3D printed case of the robot?
Yep, exactly. And in all the hoverboard designs, that part is also plastic. So the only metal part is the bracket on top.
Okay, and then there's like washers or something that those bolts are screwing into, or do they screw them in from the bottom when they're doing it that way?
In our designs, we bought these square bolts. Let's see. Yeah, you can see these square bolts that you screw into, and that's a nice way of locking them in place.
Oh, I see. Okay, so that bolt is then compressed into the plastic.
Yep, exactly. Yep, and for this design, we actually we tried completely getting rid of that the bracket, the metal bracket, and this is just sandwiched between 2 plastic pieces, and so no metal involved anywhere. And this was actually the one that we used to carry around Davis, who's 300 pounds, and so it holds up very well for just being completely made out of plastic.
Somebody asked a question about how many motor controller boards are required. I assume it's 4.
Yep. Yeah. So this one's a dual dual channel, so you just need 2 of these because each one does 2 motors. But on our custom boards here on the right here, you can see we had 4 individual ones, because we're basing our designs, our ESC designs, on this Infineon ASIC that does brushless motor control. So for a $1 chip, you can do brushless motor control. But then that $1 chip became unavailable. But yeah, so you need 4 ESCs.
And do you get any odometry back from those, or is it completely open loop?
You get odometry back. So each of these hoverboard motors has 3 Hall effect sensors mounted 120 degrees apart, and so it's giving you ticks for each whenever the permanent magnets are crossing the path of one of those Hall effect sensors. And so
but that's a few inches of travel, right? Isn't it, or an inch or 2?
No, because each of these has 30 poles. So 30 permanent magnets.
So it's multiplexing. Nice. Okay. So
Yeah.
so about, what is that, like sub quarter inch or something like that?
Yeah, I would say it's probably around like a few millimeters of travel between the encoder ticks. And so what we learn most motor controllers do is, for low speed control, you'll use the encoders. But then once you get spinning fast enough, it'll switch over to using the back EMF of the motor. So it'll actually sense as the wheel rotates, you get some voltage going up the phase wire, and it will actually sense when that's happening and just change which coils are on based on that. And you can do that a lot faster, so you can travel at higher speeds if you do this hybrid control mode. Let me go look at there's questions in the chat. Okay, I see a question. How's the data exchange with the encoders or back EMF? What exactly does that question mean?
I think the question is, how do you get the data out?
From the motor. So for the encoders, there is a 5-pin connector, and I think the 5 pins correspond to, like, 3 of them are used for the Hall effect sensors, and then there's like a power and a ground. But for the back EMF, you're actually just using the actual 3 phases. So the 3 wires, that are sending power to the different phases of the motor. You have a current sense resistor that's measuring what's going on with the current flow. And you also have a voltage measurement. And so you're actually just using those same measurements to measure the back EMF. So there's not like a digital protocol involved in any of this. It's the Hall effect sensors that you're just reading with an analog pin, or the actual phase wires themselves that you're measuring the voltage off of.
So you're actually just looking at the raw signals.
So is that built into those controllers that you used in your prototype?
Yeah. So that's one of the cool things about the Infineon chip, is that it supports encoder only, or back EMF only, or a hybrid approach. And so you might want to use like back EMF only if you don't care about low speed control. So like a lot of the electric scooters will require you to kickstart them so that the wheel's already spinning, and that's because they don't have encoders on the wheels. So they just do back EMF control, but then they don't have good low speed, so they require you to get the motor started.
So Nick, I think one of the questions people may have is, I think what you're talking about in terms of encoders and back EMF and so on is the information going from the physical motor to the controller. How do you? I assume you have access from your computer that's talking to the controller. You have access to that encoder information. Is that over USB or some other channel?
So for the open source motor controllers that we used for the prototypes, the FlipSky ESCs, they support either USB or CAN. So you can if your computer has CAN, you can hook up directly to the CAN bus, or if not, you can hook up via USB, and then you get the encoder data. They have a couple STM chips that are doing that, reading in the encoders ticks for you, and then interpreting them, and then sending it over USB. For our custom ESCs, we were planning on doing not only CAN and USB, but also Ethernet, because Ethernet is, I think, a pretty good protocol going forward, because of its higher data rates. You can kind of tell if you have 4 motors going over USB, you can start to tell the delays, and you're not able to hit the sample rates that you want with each motor.
But you would use Ethernet over CAN?
I think since we were planning on since we sell to people who are mounting computers to it, a lot of computers don't have CAN, and so Ethernet has the advantage there. I'd say if you just compare the two side by side, CAN's very tempting, but given that like the Jetson Nano in particular, and like the Raspberry Pi, you'd have to have external CAN circuitry. So it was just easier to support Ethernet since both those have an Ethernet port.
And so what controller, what's running the IP stack on the motor controller?
Yeah, we picked out an STM chip for that. So I think it was like, I'm forgetting the exact model number, but it was like the minimum one that had enough IO pins and Ethernet support.
Mm-hmm.
Another cool thing about both the motor controllers, the open source one and our custom one, is that they both did what's called FOC, which is a fancy acronym for saying that when you're changing the coils, which coils are on and off, instead of just flipping the switch, you actually do like a sine wave, and you ramp it down and then ramp the next one up, and so you don't have those sharp edges, and that makes them a lot more efficient. And you can actually, with the FlipSky motor controller, you can actually turn that on and off. And when you turn it off, the motor makes a bunch of noise, and you can actually hear the motor inefficiency, and you can see the extra power consumption, which is pretty cool to see, just what switching from using sine waves to square waves will do.
It's a field-oriented control where they're basing the control field, the control signal on what the field is currently doing. So it's in a feedback loop, which is really good. Yeah.
Yeah. Yeah. You have.
Hey,
you have to,
go ahead.
Go ahead. I was just gonna say, in order to do it, you have to sample like your encoders or your back EMF like 10 times faster than doing just normal BLDC control. But since STM chips have gotten faster and faster over the years, a lot of people are using that faster clock rate to do FOC effectively. And on the ASIC, the Infineon ASIC, it just does it on the ASIC, which is really nice.
I keep thinking that these hover motors are just absolutely fantastic because they're just
Yeah.
about in the midpoint between like stepper motors and DC motors. They have like all of the advantages of both. The only problem with them is the expense of the controllers, which is just crazy. And I keep expecting the cost of the controller chips to go down, but you know, for whatever reason, maybe because of the pandemic or the chip shortage or whatever, that just hasn't happened. But man, someday controller prices are going to crash, and because you know, silicon is cheap, and everybody's going to suddenly go to hoverboards. But for now, I'm still using DC motors in most of my stuff just because it keeps the cost down.
Yeah, that is true. And another thing we're considering once the chip shortage is over is just posting our ESC, our custom ESC for sale, because we saw the same thing. Like compared to like DC motor controllers, you can get for, you know, tens of dollars, but a nice brushless one will cost you well over 100. But if you look at like a hoverboard, they're selling a whole hoverboard for $100 that includes 2 brushless motor controllers.
Right. The only way to do it right now is just go down to Target or wherever and buy one and take it apart and like figure out how to control it, you know. So I haven't seen a lot of guides on like, well, I don't know, because you've probably done this a few times. I haven't, but are they all pretty consistent? Is it easy to tear into them and figure out how to control them, or are they all different?
Well, so the problem with the hoverboard controllers is that they're not, all they're doing is like taking an IMU to sense what direction like the kid is tilting, and then feeding that back directly into the motor controller. So those motor controllers don't.
You have to figure out the protocol, right? You have to decode the protocol in order to be able to talk to it.
Yeah, it was not made to. Yeah, exactly. It was not made to be talked to from a computer, and so you have to really dissect it in order to talk to it and command it. So.
I'm curious how you're making a living at this. Are you selling enough of those kits that pays the bills? Do you have a day job? What are you doing?
No, this is my full-time job, and we make enough to support. We're a 5-person team, so we're pretty small, but we sell enough of our hardware to support us.
I'm really glad to hear that. That's great.
Yeah, and it's a lot of our Rover Pro really keeps us going. That's it's the most expensive one, and it's the one that I'd say least passionate about, because we want the lower price points to really democratize the hardware, but it is those more expensive models that kind of keep the paychecks going. But it allows us to dip into lower and lower price points, which we like.
You know, that's exactly, you and I are on exactly the same page. I started off I'm with Haddington Dynamics, and we do this Dexter robot arm, and it started as a completely open. Well, we've always released the old version whenever we come out with a new version, and we really had hoped that more people would get into building like the early Dexter 1 and Dexter HD, but the bills are paid by megacorps buying the top end, you know, the highest, most expensive version of the robot, pre-made, pre-calibrated, you know, all that stuff. So, yeah, we're out there like, come on, hobbyists, get with it. Let's do this thing.
If you can really bring the two worlds together, like I do think that and have the same people buying the same hardware, I think that's where the sweet spot is. And but it's hard for a company to do that and bring those two worlds completely together. You have to sell a lot, high volume. And what company did you say you're with?
Oh, I'm with Haddington Dynamics, Haddington Dynamics. We do the Dexter robot arm. We had a Kickstarter.
Oh, cool. I'll check that out.
That's all open source, fun stuff. FPGA computing. One of the things my boss keeps promising to do is build BLDC controllers with the FPGA capabilities that we have. And of course, we don't have time to do that now, but that's one of the things that he recognizes as a need as well. So yeah, I'd love to see more of that kind of stuff come around.
I see a question. Any plans for an ice fishing robot? So yeah, ice fishing is pretty popular in Minnesota, and so we've had quite a few requests. Batteries get very cold, so that's a problem. But there's a lot of ice fishers that need beer and food. Run to them. So that was our idea. Put some tracks on it and go deliver some beer.
There you go.
How hard would it be to just heat your batteries? You just put a heater in there and use some of the battery power to heat it.
Yeah,
of course,
yeah.
Range, but
that'd be the trick. I think that's what Teslas do. Is that for cold weather, they have a little heater that constantly runs.
That's they had to do that on Mars, right, with the rovers.
Yeah, I think they have the advantage of the nuclear reactor that just is constantly emitting heat. But yeah,
well,
it's the same principle.
Which one was it? One of the early bots was solar powered, and that was
a
big problem. Yeah. They had
to
they had to keep it really well insulated, and then every now and again they would still have to like burn battery power, and it's like, are we going to get enough sun tomorrow to wake up the batteries? Because if they freeze, that's it, we're done.
Yep. During oh, go ahead.
That's the current situation for the helicopter for Ingenuity.
Yeah.
They fly at a certain time of day because they have to have enough time to charge the batteries for the next night.
Yep.
And they have to charge the batteries to burn off heat from the electricity in order to keep it from freezing. Yeah. Because once it freezes, that's it. You can't go back. It doesn't matter if you're getting power on the solar panels. It's done.
Yeah, I think that's what ended up killing the solar power ones came in a pair. I'm forgetting the name. I think maybe like Opportunity and Curiosity. I mix up the names, but and yeah, one of them didn't survive the night, and the battery just froze.
Yeah, they screwed up on that. They screwed up on that design because it lasted a lot longer than they planned, and so they had to have more people on the ground side, and so the budget went out of the ballpark. They were only supposed to last 30 days and ended up lasting years.
Yeah, one of my professors in my master's degree was the lead for driving the robot around all those years afterwards, and he said it drove the team crazy because Mars time is like an hour off. Every day it shifts an hour from Earth time. So if you're driving the robot, you have to shift your schedule by an hour. It's like being jet lagged an hour every single day, and it drove the team crazy until they couldn't do it, and they just had to drive it when they woke up.
And I just want everybody to know I totally did not cry when Curiosity died, so don't even think it. You guys realize Mars is a planet populated entirely by robots, right?
Well, one thing I was going to mention, if I, a cool thing I saw recently is Tesla AI Day. If any of you saw that, they recently, I think it was like about a month ago, they showed off their whole stack of how they're programming the neural nets. So I'd recommend anyone interested in that to go check it out. It's like a 2-hour YouTube video, but it's definitely worth the watch. It's very cool.
Well, we got any more questions out there? Okay, well, I think you've answered them all. Well, thank you so much, Nick. We really appreciate your sharing your product lines there, and yeah, it's cool.
Yeah, my pleasure.
You're one of those you're one of those success stories that we love to hear about. Where somebody started a robot company and they're making a living off of it. Because
yeah,
we've heard of many people that have not been successful and they've tried hard. And it's yeah,
it's true what they say about hardware being hard.
Yeah,
100% true.
100% true. Awesome. Yeah.
All right. Well, thanks, Steve. I'll send you the presentation slides in your email so that you can post those.
Post those. Okay. Thank you very much. And all right. And then and with that, I'm going to have to run. So I'm just going to stop the recording. I don't know if anybody wants to hang out on this thing and just chat among yourselves. You're certainly welcome to do that. And Nick, if you're willing to hang in there and chat a bit longer, I'm sure people would like to do that. But I'm going to go ahead and stop recording here. So thank you again, and